Good morning. I would like to thank everybody for coming today, especially Edda for giving us this opportunity to speak, Dr. Shoshana and Dr. Waterwit. I appreciate this. First off, when I'm speaking in front of large groups of people, I have a tendency to speak too fast. So if I am speaking too fast, please just raise your hand and I'll know to slow down, okay? I won't call on you for like a question, but I'll just know to slow down. The whole idea of Secure Bangkok is based around the principles of small business, okay? For me personally, when I started the company, it was something that I saw as a really large hole in the industry. The industry tends to cater to large organizations that have large budgets and can afford complex, expensive systems. So if you take that into the account in Thailand, when you're dealing with hotels, resorts, small industry, manufacturing, they can't afford large cost systems, okay? So that is what a lot of this is about, and you will hear a lot of that today when we're talking, especially the presentation on small business. Cybersecurity, we're going to talk about what cybersecurity is, why it is important, the 5 pillars that cybersecurity is based on, data integrity, who is responsible for cybersecurity, the 8 domains of cybersecurity, risk management, threats and vulnerabilities, data classification, access control, and assessment and security operations. So this is a nice graphic from ISO 27001 and what is cybersecurity, right? So cybersecurity overlaps the different areas of traditional security, from information security to critical information infrastructure protection. That would be electric power plants, things like that. Whereas information security also includes paper-based processes. And so the best way I could find to describe it is cybersecurity is a set of actions taken by stakeholders to reduce risk to systems and information in cyberspace. These actions combine all aspects of information security to create procedures addressing confidentiality, integrity, availability with critical information infrastructure protections. These procedures are made up of technical controls based on international standards, which can be audited to assess levels of risk to systems and information. That's not exactly a simple answer to what cybersecurity is. But in information security, we used to have what was called the CIA Triad. And that was confidentiality, integrity, and availability. And it was expanded to include availability and non-repudiation. Confidentiality is data privacy, right? It's how we keep things secret. We don't want to let people know, for example, at a hotel, people's passport information. And I'm going to cover this a couple times so that it gets in. Is one thing that I've seen within hotels and hotel industry is that single point systems, right? Budget in hotels are limited, so the systems that are designed for hotels are fairly inexpensive. They are designed to allow the guests on the internet. But at the same time, you have your financials, systems that are scanning passports, all this that are connected to these all-in-one devices. So throughout this conference, we're going to be talking about all-in-one devices and how they may not suit your needs, okay? Integrity. Integrity, when you think about integrity, the system and the data cannot be separated, right? Integrity means that I know that that data has not been altered or that the system has not been altered in a way. So if I can alter the system, then obviously I can alter the data. That's why that those two stay together. Authentication. When we talk about authentication, it's not just how I log into the system. It may be all the things that happen in the background as well. Think about your file server. If I need to access files on that server, what are their permissions? How can I get to that data, right? So there are many things that happen in the background that within an enterprise, people are keenly aware of. But as you go from a large enterprise and you start going down, down, down to small businesses, they don't understand these concepts and they don't have the systems in the background to employ them, okay? And they mean simple things like Active Directory or anything else that controls access to files, systems, things like that. Availability. Availability has become much more critical now that SIM, Security Information Event Management, has become more popular and used more often. If you lose data during an event, you can't find out what happens, right? So in my logging, redundancy in many different ways to make sure that that log data cannot be destroyed or lost is essential in creating a secure architecture. Non-repudiation. Think of digital signatures, right? And blockchain. That's what that is. So, to focus a little bit more on data integrity and data privacy, it evolves around the idea of how complete, consistent the data is throughout its life cycle. So since we are going to be talking about Industry 4.0 in the next 2 days as well, the pharmaceutical industry has a lot of regulatory requirements around data integrity. And data integrity and security are intertwined. So if I have blockchain as it's implemented, or just a distributed computerized system, and I have a system that, we'll keep it in the pharmaceutical context. So I have a system that generates, or makes aspirin, right? A tablet of aspirin. And in the manufacturing of that tablet of aspirin, as it's manufactured, it goes from this big vat where they mix it, and then it goes to the production line, and then they cook it, they make it hot to turn it into a tablet format, and then they put it in the packaging. I have to prove throughout this entire manufacturing process that it could not be altered, manipulated, changed. That's data integrity. And it's a bit of a different concept on security, right? But you can apply that in many different industries across the board, right? It could be Ford, they could be building cars, and they want to make sure that, you know, the mechanisms for seat belts, which is fairly important, has not been manipulated with or changed. Or maybe the ECUs that control the car itself. And since autonomous driving and all the updates are becoming more important, you can see how this data integrity issue is becoming more critical. Because in security, we can't look at just the system anymore. You have to look at the process. And the process means looking at data flow diagrams, talking to business owners, making sure that you understand what the process is that you're trying to secure, rather than just focusing on the old school traditional security of, I put my patches on, I have a firewall, and I'm good to go, right? You need to look at the entire process. So, underlying data security, data integrity protections. I just talked about this a lot, but integrity of the target data. The property of that the data has not been altered in an unauthorized manner while in storage, during processing, or while in transit, right? And transit is usually where you find most of your errors, right? Because inside an organization, people typically don't want to use encryption. Or the encryption itself is a little bit more work because inside the architecture, they don't want to do a lot of the extra work. It's time consuming. Time consuming means money, right? So when you go up to the budget and you have a project and you say something as simple as, I want to employ certificates on all these servers. And I'm trying not to stay technical at this point, but when you start doing it to a project. So capturing these types of problems and bringing it up to management so that they can make a risk-based decision is important. Also, integrity of the system processing the data. Any system, when performing an unintended function on the data, is not in an unimpaired manner and free from unauthorized manipulation, right? So we want to make sure that any system that's processing something cannot manipulate that data. So since we are going to talk about Industry 4.0, we're going to talk about IT versus OT. And when you think about these types of systems, which OT is just production, right? So if I have a production line, and this production line is, since I already used Ford as an example, we'll talk about Ford again. They're making cars. Now, these robots that are making the cars, should they be connected to your infrastructure that processes your financials? No. And that's the concept of Industry 4.0 and IT versus OT, and how you want to keep production of things with robotics separate from things that, you know, office workers, your client systems, your printers, right? Things that are producing your financials. The reason is because these devices are much more difficult to secure. These devices also need a lot of remote access from vendors to do remote maintenance. So, why is cybersecurity important? Well, it prevents cybercrime, right? And these stats are a little bit old, but it's increased exponentially since then. I can say, from my own personal experience, the number one thing I see is mafia targeting financials, right? So they send targeted emails to the customer, and it usually is to impersonate CEOs or other people that work in the financial department. They already know the vendors that they're supposed to send invoices to, and they are just fake account numbers. And I probably see one of these once a month. And these are for companies that aren't that large. Now, this is based on scale, right? The larger you are, the more of this type of event that you're going to see from the mafia. They are targeting. They make a lot of money doing this, and this is why they do it. Ransomware is the other side, but ransomware may or may not be a targeted event. Okay, we also want to reduce risk to data privacy issues, right? I'm not going to talk about the new Thai law that much because there's going to be several other speakers talking about it in depth. So, generally speaking, we also have European Union customers, and we have to worry about GDPR issues. So GDPR is the data privacy laws in Europe. And for international companies, and there are a lot probably here in this room, you have to deal with not only the new Thai data privacy law, you have to deal with the European Union data privacy law. If you're in California, you have to deal with the US privacy laws and California privacy laws. So it can be very complex and start to become, you know, a real challenge to deal with, but this is the world we're having to live in. Okay, we want to reduce risk to legal exposure as well, right? Data privacy is not just the regulations that you have to deal with from the government, but also from your consumers, right? So how is it going to impact your business from a sales perspective, right? If you're a hotel and you have a breach and all of people's personal data has been exposed, how is that going to impact, you know, people wanting to stay at your hotel, for example? And that comes into financial. And then say if it's pharmaceutical, you have what's called life science industry regulations. And that is around health information. So as an example, if you're part of a trial run and they're testing some new pharmaceutical product and you're part of that test group, would you want your personal information to be leaked on that? And what would be the impact to the company? So these are some of the areas that govern cybersecurity. ISO, which most people are familiar with, and they don't do just security, right? So you have your ISO 9001, 9015, 9001 certifications. That's not security stuff, so I'm not so familiar with those numbers, but they govern many other areas outside of security. You also have ISACA, which has COBIT 5, NIST. All these have very good guidance on how to build your internal structures for information security. Technical guidance comes from CIS, which is called the Center for Internet Security. If you're doing cloud-based stuff in Amazon or Azure, you can go to the Cloud Security Alliance. And NIST also as well has a lot of good technical guidance. My background is mostly US military. So I know the NIST regulations like the back of my hand. But along with NIST, they also have something called DISA. And DISA has extremely good technical guidance on how to secure systems. From any system you could think of, except probably Huawei, because you know the US government doesn't like Huawei, so they're not going to have any guidance on Huawei. But for everything else, yes, you can find a checklist on how to implement it. It's straightforward and just says 1, 2, 3, 4. How do I do A, B, C, and D? Now, if you're following ISO, for example, they have what's called the Information Security Management System. Okay? And it's basically how to set your organization up to identify vulnerabilities, data integrity threat systems, and data, and manage the protections for computerized systems and incident response, right? It can be embedded within IT governance, but must be independent from IT management. And I don't want to talk about ISO too much because I know we have an entire presentation on ISO by another company. But one of the most important things to understand with this whole idea is that security is not part of IT. And this is a challenge for most organizations, right? And when I say it's not part of IT, it's not part of the governance structure or how you get your funding, right? Think of it as, I have a project, and this project is assigned $100,000. Now, if I'm the IT manager, how do I make a decision based on the risk to information on how much of that budget that I give to security? So this scales. So if I'm a small company, obviously I can't split IT and security up. If I'm a company with 1,000 employees, even at that level, it's very difficult to break up. But if I'm working for some of the companies that I've worked for, which are Merck or Pfizer or things like that, security and IT are so completely separated. It's almost as separated as quality assurance. So you have quality assurance, you have IT security, and then you have IT. And IT security is basically the policeman of IT. So when you're thinking about how to design your security at all sizes, you have to think of how best to keep the separation between IT and security. Because the bottom line is that they are this policeman for IT. And there will be conflicts. You have to think about how to employ methods to reduce these conflicts and ensure the best operating environment that you can have to have the best outcome, to have low risk. Now, the 8 domains of security, this comes from what is called ISC squared. And ISC squared used to be, I guess, the best source for security people when they first got into the business. I would go get a certification which is called the CISSP. And the CISSP was considered 10 years ago maybe to be the ultimate certification you could have in security, right? And they came up with the domains for security, okay? So most security people understand this, and they understand what these domains mean, and then they apply best business practices through these domains. Now, there are 2 areas where we learn our security from, and it's ISC squared, and it's the SANS Institute. And SANS Institute is going to be speaking tomorrow. They are not governing bodies like NIST, for example. So NIST provides policy and background, but these organizations provide best business practices to achieve those things. So for training and things like that. So when you're hiring a security person and they have a SANS certification, then they have been through some good training, for example, because SANS develops a lot of this stuff on how to achieve these things, okay? So, risk management. We're going to talk about 3 areas of risk management that's important to people in the room. So there's going to be threats and threat modeling, vulnerability management, risk analysis, and decision making, okay? So threats and vulnerabilities. Okay, threats are a means by which vulnerabilities in a system are exploited and are made up of unintentional and natural threats and malicious intentional activities, while vulnerabilities are comprised of weaknesses. And just think of weaknesses in a system, right? How somebody can gain unauthorized access, how they can destroy systems data, how they can prevent an operating system from operating as you want it to be. Can they steal or manipulate critical data? Data privacy concerns, right? So, a threat, and what does it target? So, you have your threats: malicious code, insider attacks, natural disasters. Political activists is something that I've had to deal with a lot more recently than I have had in the past. And you have your targets. PII is personally identifiable information, so that would be your target for data privacy. I want you to think of targets as much more than just financials, right? When most people think of hacking, they think they're coming for your money. Think of it as maybe I'm a small IT company, and I'm a small IT company, but I do deal with several large manufacturers. And what might I have inside my company? I might have their system and architectural design data. So, a lot of these bad actors are starting to target small companies specifically for this. A lot of the cloud-based Amazon and Azure companies. Amazon and Azure companies, when I deal with them as a vendor, from a vendor perspective, they sell a product, it's an app, or maybe some other type of management tool that interfaces with SCADA. So for production, think of industry again, right? I'm a company that builds one specific robot for a company that makes orange juice. It doesn't matter what it is, right? So in the manufacturing of orange juice, they have a system that crushes the oranges. But this company makes $30 million a year. But it's only this one system that crushes the orange juice. And this company that made that system, you know, it's a company of 10 guys. And these 10 people, they have a cloud-based system in Amazon that manages this orange juice crusher. Do you think this company of 10 people have the background and skills to secure that orange juice crusher that's inside a company that makes $30 million a year? I mean, well, yeah. No, they don't, and this is a big problem, right? So a lot of these bad actors are targeting these small companies that are working in Amazon that do this type of stuff, and allows them access. Target, which happened a few years ago. Target is a company in the United States, and they came in through the HVAC system, which is, you know, it's these types of things are happening all the time from vendors, and that's why you want to keep your production totally separate, because the security of your infrastructure is only secure as the vendor that's connecting to it, and you don't want them to provide means and access into your network. These systems that they build, they're not built with security in mind. You know, they have small embedded systems in them. These small embedded systems, they don't have the processing power to do proper security. Died on me. The best way I can describe that, and sometimes it's hard to describe these concepts if someone's not technical in here, is think about what we're going to talk about with Internet of Things, right? I have an Internet of Things device, and it's this big. And it just runs on 2 AA batteries, right? How much does it cost? It costs to manufacture maybe, you know, 300 baht or less, right? So it doesn't do a lot of things. Whereas if I pull my handy out, it costs me $1,000 Australian. Why is it so expensive? It uses a lot of power. It has a lot of processing ability. It can do a lot of things, whereas this device can't do anything, right? It has one static password, and then I can jump off it and I go somewhere else. I can't manage this. I can't really log it. I can't control it. I can't see what it's doing. That's the problem with industrial control systems, okay? I can't control them. And to make things worse, usually, is they're put in by a separate company. The culture that you usually have to deal with is, don't touch it. right? Because the vendor put it in, the vendor's responsible for it, and you have no access to it. You don't have, it's not connected to your infrastructure for security purposes or for management purposes. The only person that connects to it usually is the vendor, but they want it on the network. And that's why these things need to be kept separate. Data classification. So think of it, you can't treat all data equally, right? You have financial data, you have data privacy things, corporate secrets, right? Marketing strategies. When I see lawyers using WhatsApp to send contracts back and forth, it usually gives me a really not so good feeling right here. Because if they're doing that on WhatsApp, I don't want to know what else they're doing. Think of it as how the US military has, unclassified, classified, top secret, right? Access control. Access control is restricting information to unauthorized personnel, systems, or processes. And it may not be just that you're restricting access to them. Maybe you're just preventing them from altering it. So you have different types of permissions, what's called read-only, for example. And that means that someone can see the data, but they can't change it, right? And it's based around identification, authentication, and authorization. Security tests and evaluations. You have software testing, vulnerability assessments, penetration testing, log reviews, security audits. There are many different types of testing that you can have depending on your requirements, right? So this is something that's kind of difficult to deal with these days. Is I always hear people wanting a penetration test. Now, a penetration test may not be the best thing for you, right? A penetration test can be expensive, whereas you can spend your money maybe doing a vulnerability assessment or a complete review. The reason being is many of the things that people want to have penetration tested, well, if somebody's already inside your infrastructure, you're owned already anyway. So it's kind of not realistic. So what I mean by that is, say inside my company, somebody wants to have their email system penetration tested from the inside. If somebody's already inside your company, you have much more things to worry about than just the penetration test on your email system, right? Systems that are publicly available, yes, they should be penetration tested. Systems that are in Amazon Web Services, cloud-based systems, they should be penetration tested. Azure. The reason is, when you talk about Azure or Amazon Web Services, I can build a server in 5 minutes, and I don't have to have any competency whatsoever. So if I'm building something physically in the real world, right, and I'm building it inside my company, I have to build a server, then I have to have a firewall, then I have to do all these things in the background to make sure it even works. And just in the process of making sure that it works, that security is implemented inherently. Whereas if I'm using a cloud-based system, these cloud-based systems are designed to work with everything. And a typical thing that you may see is, in the process of getting it to work, the security controls that they do have are turned off in order to get things to work. And then they don't turn them back on after they get them to work. So this is why you need to have a security assessment of these cloud-based systems for small companies that are providing services to larger companies. This is a very common problem. And it's not something that they think of inherently in the back of their mind, right? When we talked about some of the two organizations that provide these security controls, one was the CIS. CIS provides a complete list of everything that you need to do within Amazon Web Services to secure it. And it takes into account a lot of these things. Security operations. Monitoring, information security control enforcement, incident response, investigations and forensics, right? This is also based on scale and requirements as well, right? So, like I said, my background was US military. This is what I did for the US military for a very long time. And our requirements were a lot different than business requirements. So we took it to the extreme. So these days, when I look at things, I think of it in I take a much different approach, right? The problem with security operations is it's very expensive. The software associated with it's very expensive. One of these products As an example, I got a quote for Nessus. And Nessus is just a vulnerability scanner, right? And this is for a company with 5,000 systems, and it was 20,000 euros a year to just use that one scanner. So these types of things for operations can really break your budget, and it needs to really be thought of from a holistic manner and based on requirements. You want to make sure that you don't, use your entire budget on one option for doing security monitoring. So foundational concepts of operational security, right? It's based on need to know, principle of least privilege, separation of duties and responsibilities, monitoring of special privileges, rotation of job duties. Think of it like financials. And this comes back to what I was saying with the separation of security and IT in large organizations. If you're working in this operations center that's monitoring and can do security on all the systems in a company, naturally you're going to have administrative rights. And that's why you don't want people that can access and do everything on every system in the company. And this is a real challenge in security and how to separate job duties, manage, the principle of least privilege, who can watch and who can do the actions, right? They need to be separate.